Hello again. Now we're going to talk about the second section in our business math course. The objective here will be to solve linear inequalities in one variable and to introduce interval notation. Some Algebra 2 courses have interval notation and some of them don't do interval notation, so it's possible this is new to you. Let's look at what that means. Again, we're talking about linear inequalities for 1, 2. This is just a discussion of what an inequality is, which is something you should have done many, many years ago. A and B are 2 points on a real number line. The relative positions of 2 points are as follows, and so it looks here. This picture goes with this line. If A equals B, then obviously they're in the same place. If A is less than B, then A is to the left of B. If B is greater than A, then B is to the right of A. So this picture goes with that statement. If A is greater than B, then A will be to the right. If B is less than A, then B is to the left. Now, if you're still not clear on your less than and greater than symbols, this is the time to be sure that you understand which way they go. We use dots to indicate the points on a number line, and they should be spaced relatively speaking, at the spot that's correct, away from 0. So these hash marks, each hash mark is a 1 unit away from 0, and so we've got -5, -2, 7, and 9 placed on the number line. A is less than B, and X is between A and B. Then you would write that as one statement. So X is anywhere between, right in here, A and B. So your statement would be A is less than X, which is less than B. It's a compound. This would be called a compound inequality right here. So that's your compound inequality. An inequality is a statement that one number is less than or greater than, if you're using the greater than symbol, another number. Here's several rules for inequalities. I'm not going to go through these. You can look at them. You should know or be able to, this is kind of inherent that you should realize these things. Again, if you add a constant to A and B, or subtract a constant from A and B in number 1, the relationship between A and B stays the same. A is still less than B. If you multiply, if A is less than B, and you multiply by a constant, now this is key here, that the constant is positive, it's greater than 0, then that relationship will still say the same. With the multiple, and if you divide it by the constant, then A is still less than B. If you multiply by a constant less than 0, then the signs reverse. So this is that rule that you probably learned, that when you multiply or divide by a negative, you switch the signs when you're solving. This is probably one of the rules that it's stated this way mathematically, but that's in practicality what you do. You multiply or divide by a negative number. It'll be in the last step of your solution. Then you're going to turn the sign around. If it's less than, it will then become greater than. Okay, and then so on down this line. Okay, a linear meaning if graph is a line and one side or the other of the line would be shaded, can be written in the form AX plus B is less than 0. A and B, this goes back to, the y equals mx plus b. This is your line. Now in this case, when it's less than or greater than, you're going to shade one side. So the solution set of an inequality is to find all values of the variable for which the inequality is true. So that's why you have this shaded section. You do not have just the line itself, which is has the solution set. You've got the shaded section, and it could include the line or not, depending on whether you have the less than or less than or equal to. Less than or equal to would include the line. Greater than or equal to. These would include the line here as part of the solution set. The others would not. That's why, if you remember when you used to graph linear inequalities, you would have the dashed line and the solid line. The dashed line is from the less than or greater than. The solid line was from the less than or equal to, greater than or equal to. So solving a linear inequality, solve it, distribute the 2. So you have 2x minus 6 is less than 4. Then you're going to add 6 to both sides. So you have 2x is less than 10, divide by 2, x is less than 5. So it's just, you solve it just like an equal sign, basically. Just solving an equation, but you've got to deal with the inequality when you graph your answer, if you're going to graph it. This one's a little harder. We're dealing with a fraction. We have 3 halves. S minus 2 plus 1 equals negative 2 parentheses S minus 4. So, multiplying 2 on both sides right here will clear your fraction. Okay. And I would show my work here a little bit differently. Let me write here how I would show the work. I would multiply basically, let's see if I can get it all in, 2 times 3 halves S minus 2, see if I can show this all, plus 2 times 1, I'd multiply by 2 all the way across, is greater than negative 2, or 2, times negative 2 times S minus 4. And what that then would do here would be to clear this fraction. So you'd have 3S, I think it just looks a little cleaner. We have 3 times S minus 2 plus 2 is greater than negative 4 times S minus 4. Then distributing the 3, you have 3S minus 6 plus 2 is greater than negative 4S plus 16. Okay, and then your 3S, I always hate S as a variable because my S's look a lot like 5s. So we have 3S minus 4 is negative 4XS plus 16. So that gets us here. And maybe that explains this a little better. Somehow this confuses me, the way that step is written. Then we're going to add our 4S across, have 7S, add the 4 across, 20. 7S is greater than 20, so S is greater than 20/7. And then when you draw it on the number line, we normally, the way we were taught in elementary school, would have an open circle here, okay? Instead of, if it's shaded, if it was less than or equal to, then you would shade the circle, okay? But it's not. It's, greater than, not less than. S is greater than 20/7. So we'd have an open circle. Well, in interval notation, we don't use an open circle, we use a bracket. And you use a curved bracket here. So this is curved when it doesn't include the number. And I'm not sure what just happened. Oh, we moved back a page. Okay. So it doesn't include the bracket. So anyway, that's where that little curved piece comes from, because it's greater than, not greater than or equal to. If it was greater than or equal to, if it turned out to be S is greater than or equal to 20/7, okay, then what you'd have a square bracket and the line. Okay. So that's the difference, and that's where those bracket systems come from in interval notation. Okay, so that pretty much is a beginning discussion of interval notation. It's certainly not very in-depth. I'm surprised there's not more slides on this PowerPoint. So hopefully this will answer your questions for solving the odd problems at the end of this section. As I recall, there's not very many. And then we'll move on to section 1-3.